Greetings and welcome again to another one of my tutorials. My name is Clint Fleetwood and this is my Godot tutorial on using the new Astar pathfinding algorithm or node or resource or whatever it's called in Godot. Let's just go ahead and jump right off and show you what we have going on here. This is a simple little grid that I've set up, and I'll show you how we do that in a little bit. And really all you do is use sliders and you kind of draw the lines using Astar pathfinding, and it's pretty simple, you know, the technicalities of doing this aren't important. I used the sliders instead of using mouse touch just because that was a choice I did right now. And I'll show you how I did that in a few minutes. So that's simply, you know, the simplest way of putting it. That's how Astar works. It finds a path depending on, you know, the start location and end location. It tries to create a path to it. As you can see right now, this one is making a path with cardinal directions, which is up, down, left, right. Actually, it would be north, south, east, west, but you know, on this is up, down, left, right. You can also make it with all directions, so it goes at an angle, if you want to, or cardinal direction. And what basically we're doing here is changing this from having connections just between the up, down, left, right, which cardinal is, to actually having connections between the angles as well. And we'll go over that in just a second. Now, before we get much further in this, you know, you may ask the question, well, why would you use this? And I've actually heard this in one of the forums. Why would you use this instead of using the navigation mesh? Because the navigation mesh is very, very good. And it's a valid question, because this is actually very new. The navigation mesh has been in Godot since 2.0, I believe, and this is going to be in 2.2. So my answer to the question is, when you're making a strategy game or a game that is tile based, this is actually really helpful because you can add weights to each tile. And so instead of just based on just distance or height distance or anything like that, it literally can be you can make it one way more than the other, and so the height and distance don't really make as much of a difference with this, and that's pretty important. The other thing is it flows well with the concepts of strategy games. When you're already on a grid, it actually does help a lot. I did talk about in the forums that I was going to make one for using the hex, and I will do that probably next week or later. But I started working on it, and I realized that this may be a little simpler, just to go ahead and get the basic understanding of how the Astar algorithm works. So I'm going to go over several different points, and I'm going to try to make this a little bit quicker than my last couple tutorials. So let me show you what we've got. Let me close this down. So with Astar, you actually have to have a grid. I think, well, it doesn't really have to be a grid, but it basically has to be a map, a way of connecting different nodes to each other. Now, the nodes are not like Godot's real nodes. They're not necessarily that. It's kind of, I guess, imaginary nodes, but that you still need to be able to connect them, because I don't actually. If you look back at my my world, there's nothing real there. It literally is just using a single line draw. These are not like individual squares themselves. It's just lines drawn on an empty space. So it doesn't necessarily have to be connected to a real node or a real tile, but it can be, and you could actually have it. You know, it's pretty flexible in that regard. So I'm really happy with it. One little caveat before we get started: this is not on. You can't download this yet. You would have to create it from, compile it from source. But it will be in Godot 2.2, which should be coming out very soon. There are some places that you can download the 2.2 version, and I'll probably link to those later on. So this is just getting started, and this is actually pretty a simple set of scripts. You see, it's not very much, less than 100 or so lines, and most of those lines are actually the drawing methods. When we set up our scene, I've got a couple things that are important, and a couple things that are not. The 2D, this is just GUI stuff. That's all this right here. This actually could be handled by clicking, pointing, or whatever, so I'm not going to go over that too much. I will give the source code out so you can look at it and see if you want to. These guys right here are literally just the different drawing items, and they have different colors. So this one has a material, the grid itself has a material that's just blue, and its line, and if you look at that material, its line width is 1. And then you have the obstacles, which has a yellow material, and we haven't talked about those yet, but we will. It has a line width of 5, and then you have the draw items, which is the line that you go is red, and its line width is 6. And then you simply have a camera. As you can see, I'm doing this in 3D. You could technically do it in 2D as well, even though you do have to use vector 3s in the Astar algorithm or the Astar node at this point. You could pretty easily. I've essentially made it 2D, and this could be very easily translated. You just change when you draw back the vector 3s. You just convert it to vector 2s if you have to draw something, and that'll be pretty easy to see when you do it in 2D. I might show an example of that later or my next tutorial, but I just kept it in 3D to make it a little bit easier. And then we have the camera. So that's all we have to set up, and just a light, just so it's not all black. Really simple setup, not much going on. And then this is just a spatial, that's the world. So we have two different scripts here. We have the get value and the world. So where the get value only has to deal with the GUI. It's when you change the sliders up and down, it changes the value and then emits a signal. And the world is actually looking for that signal down here. So that's, again, we're not going to really go over that, but that basically tells it to do something when you move the sliders. So to set up our grid, on this simple square grid, you just basically need to know how many columns and how many rows you have, and the tile width and tile height is mainly for the drawing purposes. So you have the rows and the columns, and so I just set it up here as a global variable inside this node, and then the tile width, tile height. The path type, you have the two different types that I showed you, cardinal and all. And then here's the grid, and the grid, and this, some people may not like the way why I do this, but it's just something I do. I always like to have a dictionary of my grid. It's when I'm making a strategy game, because like it could actually keep information about who's on that item, what characters, what units are on that node item. It can say, if there's damaged or if there's some kind of resource or something like that. And you can grab that, and it's really easy to save as a JSON file, and then you can actually turn it into a binary file also and save it as data. So I like to do it that way. Somebody might have a better idea, but this is just my personal way of doing it. And then I create the new Astar object. And then I have just obstacles, which is an array. Now, one thing about the Astar that I personally don't care for too much, and I've put a request in to have an option to not, but I don't know if it'll happen or not, is that Astar requires the IDs of each node to be an integer. And that's good because it's fast, it's very clean. But one of the problems is that you can't tie it directly to a grid item as easily if you're running your own grid, or if you're using a different type of software that interacts with Godot's grid. For example, my Hex module uses vector 3s as the IDs, and that's not as efficient. But it makes it where I can literally just grab those a lot quicker and run with them, and it makes the setup considerably simpler. But as it stands right now, Astar requires an integer for its ID, and so I've used that. So as we enter into the world, we first see that we're going to run make grid. Make grid's pretty simple function. It's a pretty simple function. You have the grid, which it basically repeats itself right here. I went ahead and changed it so it can override itself if it needed to. It's not entirely necessary. Like if I wanted to remake the grid, make it bigger or smaller, whatever. And then this is just a double for loop. well, actually a double while loop, because while r while r, which is 0, is less than the grid rows, it goes ahead and creates my my grid dictionary. And I'm not going to explain it too much, but I also put in the neighbors with my hex grid. I actually have an algorithm that pulls that for me, and I probably could have done it with this, and you guys probably can too, but it's not that difficult. I just went ahead and put in the algorithm for each neighbor: up, right, right up, right down, down, left, left up. And so that way I can grab the neighbors pretty quickly when I'm making the connections. And then this is the actual point that's on the grid. This is actually like the top right corner, but it's like what also be called in a lot of different systems the grid name. It would be the X and Y. You can see I used vector 3s here because that's what Astar is looking for. And to do it on 2D, you actually literally just put 0 in for the Y if you're looking down at the top, and then you have the Z, which equals to your Y when you're looking at 3D from just the top like that. So it keeps it on a flat plane, so it doesn't go up and down. And then when you convert that to 2D, it would be X, Y, and so your X would be X and your Z would be Y. But that's pretty self-explanatory. And then you got the center point for the each grid item, and that is simply you find the and I had to make it floats. If not, the numbers are kind of funky. It actually just since tile width is an integer and C is an integer, it would actually convert it to an integer. That's one of the things about GDScript. If you're coming from like JavaScript, you have to remember to do that. If you're coming from C++, it's probably already ingrained in your head to make sure that happens. But with JavaScript, you could actually add an integer to a float and it becomes a float. With this one, you actually have to specifically tell it to. But this is basically you take the location, the central point, then you add the tile width, and then you divide it by 2, and that actually tells you where it is in the world, the columns and the rows. Alright, and so that's really just setting up my grid. That is what creates the grid dictionary, and it's you can pull from it and draw from it as you need to. And then right here you just add the A* point, because that's important. If you don't add each point, it will not be able to be used in the pathfinding algorithm. And then this is just finishing up the loops and changing the IDs to be simple integers. Alright, so we see that that's what happens when you do make grid. Alright, so that makes a grid, and then drawing the grid is, I'm not going to go over this too much, but this basically, and yes, if you've, there's probably more efficient ways of doing this because it does draw over its own line a couple times, but this basically just draws a box. That's all it does. And I go ahead and clear it out in case I needed to redraw it, but it just draws a box. So, and this is an example. I saw how to do it, and I didn't really take much effort because I really wouldn't use this so much. I would probably use something else. But this is just for that example. So the grid's drawn, and when that happens, you can actually see the grid. So basically that just runs these two, and you're ready to go. Alright, then the next thing, what happens, the next default setup that happens is it creates the cardinal connections. And where you can find that is right here. And what this does is it finds every tile. I name it tile, it could be node or whatever you want to call it, for every tile in the grid. And that's not true anymore. For every tile in the grid, we want to find its IDs. Excuse me, we want to find its neighbors. Well, we could get all the neighbors, and we'll do that when we connect all, but for cardinal, we only want to make connections on the up, right, down, and left. So what we do is we get the direction IDs, and that's pretty easy. This is where it would be easier if the A* was able to use something besides an integer for an ID, because I could literally just put the IDs in of the directions, connect it, and it'd go on its way. But this one, I actually have to find the neighbors using, converting between the IDs and the actual point it is. And that's all this does right here. It just looks through your directions, finds if it's in there. If it does, is it puts it back, and then it returns this array of actual Astar IDs now. And that's what you want. So then this would be considered Astar IDs, not yeah. And so then you would just for each one of those, if it's already connected, it gives you an error. It's actually a debug error, so it doesn't stop the game, but it just fills up this debugger with all kinds of nonsense. So it's best just to check to see if it's already connected. So if it's not connected, then go ahead and connect those points. And so that only connects, each one has 4 points in a direction. What it also does is, if this neighbor, let's say we're at like 0, 1, then it would be off the grid, and this prevents that connection from happening, so it doesn't go off the grid, which is, important. So that's really all that happens when you first start it, and then it checks. Then it checks to see if you press the button draw coordinate path or draw all path. So like I said, that's really all you have to do to set it up and to get rolling with it and get started. And as you can see, we can draw all these kind of things, make all directions, and it changes it as we go. All right. So now, one of the valuable things, now if it was just, if Astar really didn't have to worry about obstacles or weights, then, it'd be kind of a waste of energy because the calculations are pretty easy. But when you start throwing in obstacles, that's where things can get a little tricky and a little difficult. And so that's where Astar really, really does shine. I'm not going to give an example of weights right now because I don't want this recording to be too long, but I'll probably do one early next week with my hex module and using weights, so we can kind of mix two different things together. But anyway, so what we do need to add the obstacles. Now, the Astar does not natively at this time, at the time I'm reading this, have the ability to add just obstacles. So what you're doing instead of adding obstacles is removing the connections. The other thing it doesn't have the ability to do is, at runtime currently, it does not have the ability to change the weight. So, one of my suggestions or my way of thinking was like, okay, if there's an obstacle, I could just make the weight like 10,000 instead of 1. But you can't do that at runtime. You have to do that when the node is added. So the best way that I've found to add obstacles is to actually remove the connections from the from the node itself. That way it won't find a path through it. And that's real simple to do. If you look at my add obstacle button, and it adds an obstacle. So if we go up here, add obstacles right here, it finds the vector 3. And this is actually, okay, so the vector 3 is just these two numbers. That's all it is. The 5, 4, the 5 and 4. So what it does is it gets the 5, the columns, and then the 4 right there, and then makes a vector 3. Then it looks for, in the grid, if any of those points have that location. And if it does, then it says, okay, that's the tile I'm looking for. And then what it does is it goes ahead and disconnects the points for that tile. And the disconnect point is really easy. This is actually, okay, it starts right here. I did it like this for some reason. So it does this, and then for each point, it disconnects that point. Sorry, it's right here. Sorry, man. But what we have is, and this goes and finds all the directions, even if it was cardinal, it's still looking in these. I could say if it was cardinal, just do the 4. If it was the other one, not. But that's not really big of a difference. Anyway, so what it does is, for every one of these IDs, which it finds that ID, it says, are you connected? If it is connected, it just disconnects it. And that's simply all it does. And this is pretty much how it works. So we're going to add an obstacle right here. Add an obstacle right there. Now let's go ahead and add an obstacle right there. And then up, move it down, move it down, 4. And this is maybe not the best way of doing this, but yeah, not a big deal. Alright, so let's say we want it to go from here to here, and that's probably, so we start the column right. Oh, if it does end in or start inside of an obstacle, it won't work. That's just the way it is. But as you see, it's working its way around the different obstacles to find the best path, and that's because each one of those items was disconnected. Now, I don't have a remove obstacle option right now on this, but it's pretty simple to do. You would actually, instead of just doing the disconnect, you would actually be connecting back to its neighbors that you wanted. And so then that goes like that. Anyway, so that's a pretty simple overview of how the Astar works. It is very effective. It's very fast. The slowest part is me clicking that. That's the only time it has a hiccup, but that's because it's disconnecting everything and reconnecting everything, just because it's changing the directions. That probably, if I was going to do that in a real game, would probably be threaded or something like that, so it wouldn't, so because that did take a little bit of time to do. But otherwise, it's really, really effective. I really have enjoyed getting to use it some. I think it's a really, really well made Astar algorithm. So next week, I will probably do this again, but with my hex module that I've already created and using weights. So I would love it if you would give me some feedback, tell me what you think. Also, remember, I still have my Greenlit campaign going for the game that me and the kids have made. We're using actually our hex grid algorithm, and so I'd love for you to go ahead and give us a thumbs up on Steam. And finally, if you really thought this tutorial was helpful and useful, and you would like to support making more of these tutorials, I'd love it if you would just become a Patreon. You can be a Patreon for as low as $2 a month, and that'd be really, really help me be able to do this and teach the kids that I teach how to make video games. Thank you for your time, and let me know what you think.